Hi folks. Today we're going to learn about arithmetic sequences. A sequence is just an ordered list of numbers, patterns in a list of numbers, and I'm sure you've seen these before. For instance, write the next three terms of this arithmetic sequence. -7, -14, -21, -28. And so we're going to learn how to kind of look at those, interpret those, and also to come up with an equation that expresses them. So let's look at this example. First of all, if you're not clear on that ellipsis notation, it just means and so forth. So it means that the pattern continues in the same way. And one of the handiest ways of looking at an arithmetic sequence is just to put it in an organized form, use a table. So term number 1 was -7. Term number 2 was -14. So if I just kind of continue this pattern, -21, -28, I need to look at that pattern, and I can see that each time I get the next number in the sequence, I go down by 7. So if I continue that pattern, -28 minus 7 is -35. -35 minus 7 is -42, and -42 minus 7 is -49. So I can quite easily complete the next three terms of this sequence just by following the pattern. What you should notice, hopefully, and perhaps if you don't notice it there, let's just do one more example. If our pattern is 4, 8, 12, 16, and I go ahead and graph that information, let's see, so I've got a data point at 1 and 4, a data point at 2 and 8, at 3, 12, at 4, 16. So this creates a straight line graph, and that's true for all arithmetic sequences because they all have a common difference. What's a common difference? It's the difference between consecutive terms in the arithmetic sequence. So this kind of jump of -7 over and over again, -7, that's the slope of the line. Each next term in the sequence is 7 less than the one before, or in this case, the common difference was +4. Each next term in the sequence was 4 above the previous one, which is why we have a slope of 4 here on this line. So, taking it the other direction, if I give you a graph of data, can you determine whether it's an arithmetic sequence and then explain? Well, if I've got data points at 1, 15, 2, 12, 3, 9, and 4, 6, and if you've noticed these are all on a straight line, then we can say that yes, this is an arithmetic sequence. And it's an arithmetic sequence because there's a common difference of -3 between consecutive terms in the sequence. Each time we take a step, it's down -3 to change from the previous term. So all straight lines follow this pattern. So that's fine and dandy if you're not going too far down the sequence. If you're just saying, hey, what's the 3rd term, or what's the 7th term, maybe even what's the 10th term. But if you want to know something further down the road, like what's the 100th term of the sequence, you don't really want to be sitting there counting by -3 or -7 or +4 to and keeping track of where you are in the counting to get your answer. There must be a better way. And so that's what we're going to look at next. How do you write an equation for the nth term, whatever term it is that you want, of an arithmetic sequence? So we're going to start here with the previous graph where we were going down by 3 for each step. So the slope on that graph was in fact -3 because the slope is the same as the common difference so long as the steps are one at a time. The difference in the x value can only be 1 because you need consecutive terms in the sequence. So we know the slope is -1. We also need to know what the coordinates for the first point are. And if we look up here, I see the coordinates for the first point were 1, 15. So that's the first point in the sequence. Now, hopefully this is starting to ring some bells from you from a couple of classes ago. We know the slope and we know one point on the line. So we could use point-slope form to calculate to get us an equation for the sequence. So if we just do this in kind of point-slope form, we remember y minus y1 equals the slope times x minus x1. And then I would do y minus 15 equals -3 times x minus 1. You can see here that the equation that the textbook gives you uses different letters, but it's exactly the same formula. There's not actually a need to memorize a new formula here if you remember the point-slope formula that we learned before. But just so you understand what this notation is, this is the nth term in the sequence minus the first term in the sequence. And the d value just stands for the common difference. The common difference is essentially the same as the slope. And then n tells you which term in the sequence you're looking at. Are you looking at the first term, the 10th term, the 100th term? Minus 1. And the reason we're subtracting 1 is because we started with the first term in the sequence. And so the x value is 1. You can memorize that version of the equation if you want. I think it's easier to just use the point-slope form, and then I only have to remember one formula. This is not in a form that we can plug into a graphing calculator. We want to get y all by itself. So let's go ahead and simplify what we can here. I'll use the distributive property, so I have -3x plus 3. And on this side I have y minus 15. And now I can add 15 to both sides of the equation. So I get y equals -3x plus 18. Again, if we're going to use the kind of arithmetic sequence notation, we don't say x, we say n, so we want to talk about the nth term of the sequence. And you can talk about y, or you could talk about the value of the formula, the actual term value in the arithmetic sequence. So we use an a with a subscript n to represent that. Now that I have a formula here, I can solve for whatever term I want, either the 100th term, the 1000th term. It's quite simple at this point. So we just take this 100 and we plug it in for n. So we get an equals -3 times 100 plus 18. So we have -300 plus 18, which is -282. And that's the value for the 100th term. So all we had to do was use that n value given in the problem to solve for a sub n. Let's do another example. Let's look at this sequence. If we go 55, 40, 25, 10, that's the pattern for the first, second, third, and fourth terms. find the 16th term. All right, well, the slope is just that common difference as we go from one term to the next. And each time I take a step here, I'm going down by 15. Down by 15 units. Let's just fix that because that looked like 16 for a moment, but we go down by 15 units. And the coordinates for my first point are 1, 55. Remember that 1 just means it's the first term in the sequence. So the coordinates for point 1 will always start with a 1. Now plug the values into the point slope formula. I have y minus y1 equals m times x minus x1. My y just stays as the letter y. I subtract 55, the y value from my point. The slope is negative 15. My x stays as an x, but my x1 has a value of 1. And this is an equation, but it's not in a form that I could plug into a calculator or anything like that. So I will go ahead and do the distributive property here, negative 15x plus 15. And if I add 55 to both sides of the equation, I get that y equals negative 15x plus 70. Again, if we want to use the standard arithmetic sequence notation, I would say a subscript n equals negative 15 times n plus 70. So how do I find the 16th term in the sequence? I just plug the 16 into my equation. A sub n equals negative 15 times 16 plus 70. So that's negative 240 plus 70, which works out to be negative 170. Much easier than trying to just skip count and keep track of what number you're on. How about a real-world example? The textbook wanted me to do something about buying an electric heat pump, and I thought that would be less relevant to people's lives than buying concert tickets. So here we're going to buy concert tickets for Taylor Swift. Somebody's put them on sale on eBay for a minimum bid of $420. And those tickets increase by $25 for each bid. Write a function that represents the arithmetic sequence. So we know that we go up by $25 on each bid, so we know that the slope, that common difference value, is positive 25. We also know that the original bid was $420, so that we know that the point, our starting point, is 1, 420. So we can use this formula, the same as we have before, to do the point slope formula, y minus y1 equals m times x minus x1. Plugging in my values, I have y minus 420 equals m. Remember, m is the same thing as d. It's the same thing as the common difference, slope and common difference. So I'm going to plug the 25 in there. X minus 1. And now, before I solve for y, I'm going to do the distributive property here. 25x minus 25 equals the y minus 420. And if I add 420 to both sides of the equation, I get y equals 25x plus 395. Now that I have the equation, I can make whatever predictions are being asked of me. This question is a little different than the previous ones. In the previous ones, I said, hey, what's the nth term? What's the 100th term? Or what's the 50th term? What's the 16th term? This time, I'm telling you what the final answer was. The final answer was $1,520. how many bids were made is the question. So here, instead of giving you an X value, I'm giving you the Y value. So I'm telling you that the final answer was 1520, and I'm asking you to solve for X to figure out how many bids there were. That's not a problem. We can do things in that order too. How do we solve for X? We go in reverse PEMDAS order, so I'll subtract 395 from both sides of the equation. And on the left side, I get 1,125. And on the right side, I get 25x. So now I divide both sides by 25 to get x all by itself. And I get that x equals 45. So I know that there were 45 bids to get those Taylor Swift tickets. I hope this helped.